So next we're going to take a look at natural gas and again evaluate it based on net energy that can be extracted, availability, and the impact on the environment and human health. So first let's get a further definition of natural gas. It can exist in two ways. One is as a component of petroleum under the ground. It can also exist as separate gaseous deposits. And the natural gas that we have in the United States is largely from these separate gaseous deposits. There are 4 types of natural gas. The first is methane, and that's the largest amount or the greatest amount of natural gas is methane. And it consists of 1 carbon atom and 4 hydrogen atoms. These other forms of natural gas, which you have probably heard of before, ethane, propane, and butane, have additional carbons. So methane was 1 carbon with 4 hydrogens, ethane is 2 carbons in the molecule, propane is 3 carbons in the molecule, and butane is 4 carbons in the molecule. Once you get to a chain of 5 carbons, it can no longer exist as a gas. In addition to these natural gas compounds, there is something called liquefied natural gas. And that's taking usually methane and applying some human technology to it to cool it down, super cool, down all the way to negative 260 degrees Fahrenheit and under pressure. And when introduced to these very cold temperatures and high pressure, you have a form called liquefied natural gas, which can be transported, and it can be used to supplement your other natural gas supplies, particularly during the winter when there's higher demand for natural gas. Unfortunately, this form of natural gas is also highly flammable. So they used to bring it in to ports in major cities like Boston. But since the 9/11 terrorist attack, that's no longer done because of a concern that if there was a terrorist act which caused this to catch fire, it would explode and do tremendous damage, not only structurally, but to human life. And plus, an accident could occur as well. So now it's usually brought into very few ports. There's one in Everett, Massachusetts, that accepts this form of liquefied natural gas, and there are 2 facilities off of Cape Ann, offshore, not directly into the port, but offshore, that accept the liquefied natural gas. So let me step back a minute and talk about the importance of natural gas. It's very important in the U.S. energy profile because it's very flexible. Natural gas can be used to make electricity. It can be used to heat our homes and buildings. It can be used for cooking. It can be used for industrial processes. And it can be used to create nitrogen fertilizer, synthetic nitrogen fertilizer is what I meant to say. So it's also very abundant. And so for these primary reasons, the use of natural gas in recent decades has accelerated. So let's look at the fracking process, and then we'll look at the availability of natural gas in the United States. So the process of extracting natural gas from the rock below is called hydraulic fracturing. Some people refer to it with the nickname fracking, but it's called hydraulic fracturing. And what you have is a well that's dug deep into the ground, and it may go past layers of rock and sand, for example, and it goes deep into the ground to extract the natural gas from down below. So you'll notice it's called hydraulic and it's called fracturing. Great amounts of water, chemicals, sometimes sand particles, are injected into the well and used to break up or fracture the rock that contains the natural gas. The natural gas is typically not sitting there in a big pocket like a cave. Same way that our aquifer is not just a big bowl of water underground. It's water within porous rock. In this case, the rock is not very porous, so there is an actual process of injecting this material in there so that the rock can be broken apart, and the natural gas, being lighter in density, will then be able to be extracted. So some of the considerations that we want to make when looking at fracking is that 70 to 140 billion gallons of water are used each year in just the United States. That's approximately the annual water consumption of 40 to 80 cities with a population of greater than 50,000. Secondly, we want to consider the sand or ceramic beads that are injected, and there are 300,000 to 4 million pounds of propents. These are things that hold the rock, once it's been broken, hold it open essentially by jamming little pieces of sand or beads in here so that the gas can flow out. And then there are chemicals. Chemicals can make up to 2% of the fracturing fluid or the water that's injected, and there are up to 330 tons of these chemicals. Now, what chemicals are being injected? So that's a very interesting question, because it is a proprietary secret. The natural gas companies are not required to tell anyone what chemicals are being used. Now, that is an issue because other organizations have gone in, things like the EPA and some nonprofit organizations have gone in to measure the leftover water to see what went into these in the first place. And they have found many compounds that either are known carcinogens or have the potential to be carcinogenic, particularly in higher quantities. And so that right now is not as regulated as one would hope, so that is also an issue. Another issue with hydraulic fracturing is that it can produce small earthquakes. There have been a few, one in England that was a 2.0 earthquake, so these are minor earthquakes, but they have been known to be caused, and in some cases the companies actually admitted to causing the earthquake. Now, the other problem is that sometimes the natural gas that's being extracted is near a water body that is being used as an aquifer, so groundwater that is being used for drinking water. And when it gets into that water, into that aquifer, it can essentially permanently damage that aquifer. And you've probably seen videos on the internet where someone actually turns on their faucet and in addition to the water coming out, they can light a lighter and their stream of water catches on fire. So that would be an extreme example, but even at lower amounts of contamination can also be an issue. So let's look at the abundance of natural gas in the United States. This map is from the Energy Information Administration, and you can see different amounts of different basins that contain natural gas. And again, remember, this is not just a nice little pool of it, it's within rock. And the ones that are in this pink are current plays, which are areas where natural gas is being extracted, and prospective plays where it may soon be ready to be extracted. And that's because there are high concentrations in this area. There may also be undeveloped land over top, often farmland, that people are willing to sell to the energy companies, whereas you wouldn't be extracting it, say, underneath the city of Boston. So it has to be in a sufficient quantity and an area that was rural over top of it. And you can see the one where we get most of our natural gas is from the Marcellus basin, and it covers areas of New York, Ohio, and Pennsylvania. And you can see that then it wouldn't have to be transported very far to get to Massachusetts. And you can also see that some of this is associated with oil drilling areas such as California, and what else do we have down here? Some of the other areas near the Gulf of Mexico, for example. So some of those are associated with oil drilling, but some of them, like this one, are mainly from just basins of just natural gas. Okay, so the next chart from the textbook on the advantages and disadvantages of natural gas. It contains fewer impurities and therefore emits almost no sulfur dioxide and no particulates. And it emits only 60% as much carbon dioxide as coal. The disadvantages are that when methane escapes into the atmosphere unburned, it has more capacity to warm the atmosphere than other things such as carbon dioxide. And so that creates a problem. It's actually 25 times stronger greenhouse gas than carbon dioxide. So even small amounts of it can produce a lot of global warming. Another issue is the exploration of natural gas has the potential of contaminating groundwater, and this has happened many times before, unfortunately. Okay, last I'm just going to look at two other types of fossil fuels, and then we'll move on. Oops, actually, no, I have one slide first. This slide is chock full of words, and I just want to run through that with you. Not expecting you to memorize it, but to give you some details on hydraulic fracturing. In 2004, the Environmental Protection Agency did a study on the impacts to underground sources of drinking water by hydraulic fracturing, okay, what they call coal bed methane reservoirs. So those big hydraulic fracturing areas that you saw, how much did that impact underground sources of drinking water, that is, aquifers? And they found that 10 out of 11 of these reservoirs were located within underground sources of drinking water. So that's a very high number. They also found that during the course of normal fracturing operations, hydraulic fracturing chemicals were in some cases allowed to be injected directly into U.S. drinking water. At least 9 of the hydraulic fracturing chemicals were injected in concentrations high enough to pose a threat to human health. These were anywhere between 4 to almost 13,000 times the acceptable concentrations for U.S. drinking water. Remember those regulations that we talked about in monitoring drinking water. Next bullet point, according to the EPA studies conducted by oil and gas companies and interviews with industry regulators, about 20 to 85% of fracturing fluids remain in the formation after completion of hydraulic extraction. So that means prolonged chances of contamination years after drilling operations have ceased. In 2005, a law called the Energy Policy Act exempted oil and natural gas companies from such policies as the Safe Drinking Water Act, the Clean Water Act, the Clean Air Act, and the Comprehensive Environmental Response and Compensation and Liability Act, which is also known as the Superfund Law, by limiting regulation of fracturing only to the act of underground injection and nothing else that takes place. Okay, that will be a wrap for this section, and we'll move on to another screencast.